Without any external aid, if any reactions which is happening of its own, such reactions are said to be a spontaneous processes. The degree of randomness will be decreased and disorderness will be increased, so that the entropy of the system will be increased. When the system is at equilibrium, the entropy is maximum and change in the entropy will become zero. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Thermodynamics. Under this unit, we have discussed about the Hess's law of constant heat summation, and also we have solved the sum of the numerical. Today, let us move on to the next topic of this unit by understanding the spontaneous process as well as with the non-spontaneous processes. In addition to this, we are also going to understand the concepts of entropy, as we have learned like enthalpy. We are going to understand what is an entropy and the enthalpy change will occur with the spontaneous reactions also we are going to understand in this section. First, we will see what is a spontaneous process. The spontaneous process is a reaction where it happens of its own. So, without any external aid, if any reactions which is happening of its own, such reactions are said to be a spontaneous processes. The best example is if you keep the ice cubes from the refrigerator and if you keep it outside, so what will happen? We know that the ice will melt with a normal room temperature, correct? So, for that reaction, for the melting of ice, there is no external conditions which is required or the external pressures which is required. Such reactions are said to be spontaneous processes or the spontaneous reaction, because these reactions which is taking place of its own without any external aid. Okay, we'll see what is the definition now. A spontaneous process is an irreversible processes and it may be reversed by some of the external agency. The spontaneity means having the potential to proceed without any assistance of the external agency. So, spontaneity in the sense, what does it mean? So, without any external agency, the reactions which is happening of its own, such reactions are said to be a spontaneous processes. Remember, it is an irreversible process which can be reversed back only with the external aid only. Okay. Example for this is the gas which is expanding to fill the available volume. For example, if I take a large container, to this I am going to fill with a gas molecule. Okay. Okay. I am going to fill with the gas. Now you can see that to the fixed volume of the container, I am going to fill the gas. We know that the gas molecule can easily occupy the space. So, the gas molecule here is going to occupy the space inside the cylinder. For that reactions, there is no external aid which is required. Such reactions are said to be a spontaneous reactions or spontaneous processes. The flow of water from the higher level to lower level. So, as we know that the water which can easily move from higher level to the lower level. From lower level to the higher level, if it is wanted to move it, it needs some external force in the form of a electrical current. So, the movement of the water from the higher level to lower level, it does not require any external agency for that processes. Hence, it is an example for spontaneous processes. We have one more reaction, that is flow of the heat from the body at a higher temperature to the body of lower temperature. So, for example, if you are heating a glass rod or when you are heating a metal with a flame. So, we know that from the lower part of the energy, the energy is transmitting or the heat which is transmitting, okay, when you are heating. So, from the lower temperature of the body, the heat which is moving towards a higher temperature, which is a best example for the spontaneous processes. We have two more examples. You can see that the zinc, when it is reacted with a concentrated H2SO4, it forms a zinc sulfate with the evolution of hydrogen gas. For this reactions, which takes place of its own without any external agency. We have one more reaction when a base is treated with a acid. What does it form? We know that it forms a salt and water. So this is an example for the acid-base reaction or the neutralization reaction. So these are the examples to understand what is a spontaneous processes exactly. Now we will see what is a non-spontaneous process. It is a reverse of the spontaneous processes. If any reactions which is happening only with the external agency, only with the help of external agency, such reactions is said to be a non-spontaneous processes. It is a process which do not take place of its own. Under the given condition, it requires an external aid to take place. Example, the water spontaneously does not flow from the well, so that to draw the water from the well, there is an external agent like a pump run with the help of electricity is needed. Suppose if I wanted to draw the water from the well, so it's not possible to draw the water from the well. Either we have to use the rope, either we need to use a pump to draw the water from the well. So for this reactions to happen, there is an external agency we require in the form of a rope or in the form of electricity, in the form of pump also. So such reactions which is not taking place of its own, but it can take place only with the external agency. Such reactions are said to be a non-spontaneous processes. The cause for spontaneity are the tendency to have a minimum energy and tendency to have a maximum randomness. So the spontaneity will be does not caused here. That is mainly because of the processes will have a minimum energy and also it have a maximum randomness. Now we'll understand what is the concepts of entropy. Okay. It is a measure of randomness or the disorderness in the system and is denoted by S, and the entropy which is increases with increasing in the randomness. So what does the entropy stand for? It is a measure of degree of or the randomness or disorderness of the system. So disorderness in the systems are said to be entropy, and usually it is denoted by using a term S. Okay, we'll see with an example, so we will understand what is a randomness, what is this a randomness or the entropy, why it is called as. Okay, example is melting of ice. The water molecule in the ice are arranged in a orderly manner. As the ice melts into the water molecule, it becomes less order and it can move freely. That is, the disorderness will be increases and the entropy of the system will be increased. For example, we know that in the solid state, the particles are tightly arranged. I am taking the example of the ice cube. Okay. This is how the ice cube in the solid state, it will be arranged. When it is start melting, okay, when it is start melting, okay, the molecules inside this solid will become very free, so that it will become very free, so that it will be start moving. What will happen to the order of arrangement here? The order of arrangement will become very loose in such a way that the molecules can easily flow. So as a result of this, the degree of randomness will be decreased and disorderness will be increased, so that the entropy of the system will be increased. This is the best example for the entropy. So what is the entropy? It is a randomness or disorderness in the systems. Okay. How does it cause? The best example is melting of ice. When you keep the ice cube as such in the normal room temperature, it will be started melting. Why it is started melting? Because the particle inside that ice cubes will be become somewhat free due to the melting process, it become very free. When the particles are very free, the randomness which is increases and there is a lot of disorderness in the system will be taking place, and as a result of this, the entropy system will be increased because of the disorderness. Okay. Next, we have one more example, that is diffusion of the gas or the expansion of the gas. The disorderness will be increased so that entropy of the system which is also increased. Suppose if the gas expands, what will happen? Obviously, the gas molecules, their order will be also get increased, or their order will be become disorderness, or the entire the randomness of that gas molecule will be increased. If the randomness which is increased, obviously their arrangement of the order which is also get disturbed. As a result of this, entropy of the system will be increased. So, hope you all understood with the entropy. It is a randomness or the disorderness in the system and is denoted with the capital letter S. We have few things to note with the entropy topic. We'll see what are those. The entropy of the perfect crystal is absolutely zero. What does it mean? Suppose I am taking a solid. What will happen? As we have just now we have understood that in a solid state the particles are tightly bounded and there is a order for each particle in that system, correct? For that, what will happen to the entropy if the molecules are perfectly packed or if the particles are arranged orderly, the entropy of the system will become zero. Next, the entropy will be increases with the temperature. So, obviously, when the temperature increases, the order of arrangement of the system will be get disturbed. Once it is disturbed, there is a lot of randomness or the disorderness in the system will be absorbed. So that we can say that the entropy of the system can also be increased with increasing in a temperature. Next, we have the entropy increases in the order of solid, then with a liquid, then with the gases. So, in the solid state, the entropy will be almost zero, we can say. But when the solid is going to be converted into liquid state, it is somewhat high. From the liquid state to the gaseous state, if you compare, the gases will have a more entropy. Next, the entropy of a system is a state function. It depends upon the initial and the final states of the system. When the state of the system is changed, the entropy is also get changed, and it does not depend upon the way in which the process is carried out and change in entropy. So, the change in entropy was given by the formula, that is delta S, which is equal to S final minus S initial. What does the entropy of the final means? It is a change in entropy or the entropy of the final state minus the entropy at the initial state will give the change in the entropy. And remember, it is a state function. It does not depend upon the how does the entire process which is taking place. It actually depends upon the state of the system. That is, it depends upon the initial and the final state. Okay. Next, we have few things we'll understand by taking the heat as one of the coefficient. Okay. When we supply the heat to the system at a lower temperature, it causes a greater randomness. Then, when the same quantity of the heat is added to it, at higher temperature, it suggests that the entropy changes inversely proportional to the temperature, and S is related to Q as well as with the temperature for the reversible reaction. So, here I am considering a system, okay, at low temperature. Similarly, I am considering one more system to understand how does the temperature will also affect with the entropy. Okay, I am considering two systems where one system which is having a low temperature, another system will having a higher temperature. To that two system, I am supplying the same quantity of heat. I am supplying the same quantity of the heat. So, what will happen? When the system is at lower temperature, the degree of the randomness is more. The degree of randomness will be more. When the system is at higher temperature, even though when you supply the heat, the degree of randomness will be very, very less. Because, understand here, at lower temperature, the heat which is added to the system at lower temperature, which causes a greater randomness than when the system which is supplied with the same quantity of the heat to the higher temperature. So this suggests that the entropy change in a system are inversely proportional to the temperature, and this relationship with the temperature as well as with the heat with the entropy was given by the equation, that is change in the entropy, which is equal to Q reversible divided by T. What does that Q reversible stand for? It is a quantity of the heat which is supplied to the reversible process, whereas the temperature will be expressed in a Kelvin scale. And the total change in the entropy of the system and the surrounding of the spontaneous process will be also given by delta total, which is equal to delta system plus delta surrounding, and it is always lesser than 0. When the system is at equilibrium, the entropy is maximum and change in the entropy will become 0. So this is how the dependence of the temperature along with the heat with the entropy can be understood by taking with the two example. So I'll explain it once again. Here I have considered the two systems, where one system which has been maintained at a lower temperature, whereas another system which has been maintained with a high temperature. To this, both of the system I am supplying the same quantity of the heat. When you supply the heat, the degree of randomness will be more with the lower temperature, and degree of randomness is very less in the higher temperature system. This indicates that the change in entropy can be understood by the relationship of delta S, which is equal to Q reversible divided by temperature. So the temperature which is inversely proportional to the change in the entropy. Suppose if the system is at equilibrium, the change in the entropy will be equal to 0. This is how we can easily understand the concepts of entropy. Next we have enthalpy change and a spontaneous. Generally a substance which attains a lower temperature state as a lower temperature state is a more stable. In a spontaneous process, the flow of water from the higher level to the lower level, then there is a decreasing in energy, that is more stability. Let us consider the reaction for this to understand how does the enthalpy will also get changed. Okay. Suppose A is giving rise to B. Let HR is the enthalpy of the reactant, okay, and HB is nothing but the enthalpy of the product. So what does the HR stand for? H stands for enthalpy of the reactant, HB stands for enthalpy of the product. Now we know that if enthalpy of the formation is lesser than the reactant, that is the change in enthalpy was given by the enthalpy of the product minus enthalpy of the reactant. What will happen? So we know that we will get a negative value. So this if the change in enthalpy, if it is obtained by taking the enthalpy of the product minus enthalpy of the reactant, it gives a negative value, and this indicates that it is a spontaneous process. Okay. We'll have an example for this. Okay, sodium hydroxide, when it is reacted with an acid, it gives us to the sodium chloride and water. So here if you take the change in enthalpy by considering the enthalpy of the product minus enthalpy of the reactant, it gives the negative value. Okay, this indicates that the reaction is spontaneous. The reaction is spontaneous. We have one more reaction, that is hydrochloric acid treated with water. It gives an aqueous hydrochloric acid. Okay. So the change in enthalpy for this reaction is obtained by changing in the product minus the enthalpy of the reactant, which gives a negative value. Again, this is an example for spontaneous processes. However, if you take an endothermic reaction also, the reactions which is also get spontaneous, because the change in enthalpy will be also gives a plus value. Why it is giving a plus value even though it is an endothermic reaction? So that the energy factor or the enthalpy factor cannot predict the spontaneity of the reactions. So this indicates that by taking an example of a substance where usually like to be at a lower energy state because it's more stable, I have considered the reactant A is giving rise to the product. I have considered the two conditions, one is with the exothermic as well as with the endothermic. One is in the exothermic reactions, which indicates that the reactions, the change in enthalpy is in the negative value, and it indicates that the reactions is a spontaneous. If it is an endothermic reaction, the change in enthalpy values is positive. Why it is giving positive value? This indicates that the enthalpy of the system alone cannot predict the spontaneity of the reaction. Then the entropy and the spontaneity. Consider the melting of, now we have understood that the enthalpy alone cannot predict the spontaneity of the process. Let us see with the entropy also, whether the entropy alone can able to predict with the spontaneity of the reactions, we'll understand now. Let us consider the melting of ice at a room temperature or the dissolution of the sodium chloride crystal in water. These are the spontaneous process which is accompanied by increasing in disorder, that is entropy increases with this processes. Let us consider A is giving rise to B. For the process S1 is a entropy of the initial state and S2 is a entropy at the final state. The change in entropy was given by S2 minus S1. So, if you minus the S2, that is the entropy at the final state minus entropy at the initial state, it get the positive value. Thus, the process is spontaneous and increasing in entropy during the system. But let us consider one more condition where S2 is lesser than S1. So, you will get a negative value by considering the change in entropy. So, that the process is non-spontaneous. By looking at the values, we say it is non-spontaneous process due to the decrease in entropy during the processes. So, this is also which indicates that the entropy of the system cannot alone predict the spontaneity of the reaction. So, that is why in the chemistry, they have introduced a new terminology known as Gibbs free energy. So, by understanding the Gibbs free energy, how we can predict the spontaneity of the reactions, that we can easily understand. But remember, the enthalpy as well as the entropy cannot alone predict the spontaneity of that particular reactions. So, by considering these two, we have understood that there is a separate terminology to predict the spontaneity of the reaction, that is known as what? Gibbs free energy or the Gibbs functions will be used, and it is denoted as G. Okay. So, we will understand more about the Gibbs free energy in the next class. Hope you all understood with the session. We will meet up with the last session about the thermodynamics. Till that, take care, be safe. Thank you.